Hello friends, in this video we will record for the normal form or the conjunction normal form and resolution in preposition logic. So basically a normal form is a standardized form of a representation in preposition logic in which we eliminate the imply and double imply so that we are left with only three types of operators and, or, and the negation operator. This makes it easy for the computer to represent the knowledge and also perform the proof for proving various properties, and the proof by this method is known as the resolution method. Let us look at both the concepts. So we know that a well-formed formula is a formula which consists of preposition variables, negation and, or, imply and double imply. Then in a previous video we have already looked at what is a normal form of a well-formed formula, which is a disjunctive normal form if it is a sum of elementary products, and a conjunctive normal form which is a product of elementary sums. Now in this video we will look at how to convert a sentence from a well-formed formula into the conjunctive normal form. So let us look at the steps first. In order to bring the well-formed formula into a normal form which is conjunctive normal form, first of all we will eliminate the double imply. How to eliminate the double imply? By replacing it with simple imply and the simple imply of the reverse. Then we eliminate the implication by using the negation of P or Q method. Then we have reduced the scope of the negation to a single term using the De Morgan's law. Then convert the formula into conjunctions of disjunction using the logical identities. And then we separate the clauses for all of the conjunctions. So let us look at one example to perform all these steps. So we have already discussed the Wumpus world problem in another video for writing the Prolog code for this problem. And here let us discuss this problem again and take an example of how to perform the resolution using the Wumpus world problem. So in the Wumpus world problem, there is a 4x4 matrix and there are pits at some of the cells and a Wumpus at some of the cells. So there is only one Wumpus, and the Wumpus can kill the agent who is there to find the gold. Now wherever Wumpus is there, there is a stench in the adjoining cells, and wherever the pit is there, there is a breeze in the adjoining cells, and if the agent will fall in the pit, you lose the game. If the Wumpus eats you, then also you lose the game, and if you find the gold, you win the game. This is how the Wumpus world problem is there. Now first of all we have to represent this. I will not be representing for whole of the board, but we will look at a part of the board and then you can generalize it for the remaining board. So we define a preposition variable Pij where it represents the pit in I, j cell, and then there is a preposition Bij which represents the breezy in ij cell. If a cell is breezy, that means in one of the adjoining cells there is a pit. Now we have the identity R1 which says negation of P11 which says there is no pit in the 1,1 cell. Then there is a identity which R2 which says if 1,1 is breezy, it implies that either there is a pit in 1,2 or in 2,1. And it is double implication. If there is a pit in any one of these cells, 1,1 will be breezy, and if 1,1 is breezy, then the one of the two pits contains, one of the two cells contains the pit. Similarly, we have for B21, that is cell number 2,1, either it is breezy. If it is breezy, it implies that 1,1, 2,2 or 3,1 contain a pit. And if there is a pit in 1,1 or 2,2 or 3,1, then 2,1 is going to be breezy. Then it is given to us that there is no, the cell 1,1 is not breezy, and it is given that the cell 2,1 is breezy. Now first of all, we have to represent these 5 identities into the clausal form, which is the conjunctive normal form. So we see that R1, R4 and R5 identities over here, they are already in the clausal form. So we have to convert R2 and R3, this one and this one, into the clausal form. So first we will eliminate the double implication. So simply what we will do, this implies this and then this implies this. As you can see here, B11 implies P12, P21 and P12 or P21 implies B11. Similarly, we have done for R3. So this implies this and this implies this. So you can see here we have written first part only implication in one direction and the second part implication in the other direction. Now we have to eliminate the implication symbol also in R2 and R3. For this we have a rule that P implies Q is same as negation of P or Q. So simply what we have done here, we have written this was B11 implies P12, P21. So we have negation of B11 or P12 or P21, and this one is written as negation of P12, P21 or B11. Similarly for this one also, first we negate this or this whole thing and then we have negation of this whole thing or B21. So as we can see here, we can write P implies Q can be written as negation of P or Q. So we have applied this to both R2 and R3. Now we can see here we have this statement in which the negation is applied to 3 terms and here negation is applied to 2 terms. So what we will do is we will reduce the scope of negation to a single term using the De Morgan's. For the first one, in which only 2 terms are involved, it is very easy because we will get negation of P12 and negation of P21, as you can see here. So this was pretty simple for us, but in this one we have 3 terms involved. So what we will do is first we will apply negation on 2 terms together and on the third term separately, and then again we will apply De Morgan's on these 2 terms which we will be solving together. So as you can see here, we have negation applied only on the first 2 terms together. So negation of P11 or P22 and negation of P31. So this one has come out and then we apply for these 2 terms. So we get negation of P11 and negation of P22 and negation of P31. And when we simplify this further, we will get negation of P11 and negation of P22 and negation of P31 or P21 using the associative property. Because if we put brackets here or we group the other two using the associative law, it is going to be the same thing. Then we have the convert the sentences into conjunction of disjunctions. So for R2 we can see here all the statements, they have a disjunction, then a conjunction connecting the other clause which has a disjunction, then a conjunction which has the disjunction. So how we have arrived at this? We have opened this bracket from here. So negation of P12 or B11 and negation of P21 or B11. This is what we have written here. And similarly for R3 too also we will do this. This is the R3 too. So we will open the bracket, this or this one and this or this one and this or this one. As you can see here in R3 too we have written this. So using this we have converted the sentences into the clausal form. So finally, after application of all the rules of the clausal form, we will get these sentences and we have to prove that there is no pit in 2-1 or 1-2 cell. So how we will prove this? Using the refutation or resolution method. Resolution method is a proof by refutation where we assume that whatever we want to prove is not true. And then if a contradiction will arise, that means that whatever we have assumed was wrong. And if a contradiction does not arise and it generates a clause which is already present in the knowledge base, that means that our assumption was correct and whatever we have assumed is right. So in this one we have all the rules from R1 to R5 with the various splits in the places where we have generated more than one symbols, and we have separated the connecting clauses which were connected by and we have made separate clauses out of them. And now we have to prove that there is no pit in the 2,1 and the 1,2 cell. So we will prove by refutation, we will generate a negation of this statement, which will give us there is a pit in the 2,1 or a pit in the 1,2 cell using the De Morgan's law. Now we have R6 which says, which is what we want to prove. So R6 says there is a pit in P21 and 1,2, and we resolve this with R22 which says there is negation of 1,2 or B11. So when we resolve these two, what will happen? This P12 will get cancelled with negation of P12 and we will be left with P21 or B11. So now this generates this new clause, and now we will resolve this with R23 which is negation of P21 or B11. So this P21 negation and this P21 will get cancelled and we will be left with B11. Now we resolve this with R4 which says negation of B11. So when we resolve these two, it will generate a empty set. There is no clause left. So this is a contradiction that is identified. So our assumption of refutation is wrong and there is no pit in 2,1 and in 1,2. This will hold true. So this is how we perform the resolution in the proposition logic. But when we look at this problem, do you realize that proposition logic is not sufficient for representing knowledge? Why? Because suppose I have P11 and I have the proposition P12, I have no means of identifying that P12 and P11 they refer to the pit, and 1,1 and 1,2 they refer to the same property of pit. Similarly for breezy also, we are not able to compare two clauses which have the same meaning. So this is the limitation of proposition logic which has been overcome in the predicate logic, which I will be discussing in the next video. Thank you very much for watching.